a leading coefficient, and the leading coefficient is the coefficient of the term with the greatest exponent. Okay, so the greatest exponent is 3, so 4 is the leading coefficient. That makes sense. Okay. And then we have a constant. And the constant is a term not multiplied by a variable. Okay? Just move it up a little bit.
Will our homework be on this?
Yes. But it's not due until Wednesday, so hopefully you don't take the whole period, the whole block for your test, and then if you want to, you can work together on the homework. Okay, so a constant is the term not multiplied by a 0. Okay, so a polynomial, and I want you to think about these. I want you to think about what they look like. If I said to you f of x equals 3, okay, what is the degree? If I have a polynomial of degree 0, my constant, it's x to the 0 right here. So I know 3 to any number to the 0 power will be 1 is 3. What does that graph look like? Straight line. Okay, so just make sure that you remember that. And I've just added little graphs here.
What does it say on the constant?
It's a constant function. Yeah. F of x equals 3, you know, is just going to be what? A straight line across. Okay, so how about if I have f of x is equal to 2x? What is the degree? My exponent, 1, and what does the graph look like? All right, well, this one happens to be going through the origin, but it is called, it's linear, right? It's a straight line. Y equals 2x plus 3. My exponent is 1, it's a first degree. I know that all of them are, and that says linear right here, so if you could just make sure that you write linear. Okay, the next one, if I have a degree of 2, a second degree, I know that the graph is going to be a what? Parabola, and that one is called what? That's your quadratic. We know that if it's a second degree, we have a quadratic.
How are you fitting that all on?
I know, well, I squeezed it in. Okay, and then the last one, oh, I have 2 more, sorry. X to the 3rd, degree of 3, and the graph, do you remember what that graph looks like? It's kind of like the funny one.
Half a parabola and then the other half is downwards.
Yeah.
What's it called?
It's called a cubic. And then the last one is that we're going to talk about is a degree of 4 in the graph. I'm going to let you play with your calculators in a second and just graph y equals x to the 4th.
That's also a quadratic.
No, that one's not a quadratic. That one's called a quartic. Quartic. Q-U-A-R-T-I-C. Is it the same thing?
But it's flat.
it is,
Flatter bottom.
okay, flatter,
And aren't there like two of them?
No, even.
okay. But we're gonna see what happens in a bit. All right, so if they're higher than the fourth, they're just named after the highest degree. So if I had f of x is equal to x to the eighth, I just say it's an eighth degree. I don't have a
So
special.
remove your hand.
So if it's higher, it's just named after the highest degree, and that is just an eighth degree. All right, one more thing, and then we're done, okay? Can I move this?
No.
So I will write your assignment while we're waiting.
Okay.
Let me see, page 545, 1 through 9.
This one is
Okay,
This
17. All right. So I'm going to show you another graph, and this is really just about interpreting data. So on page 544, and I don't know, I guess I like this stuff, and I'm sorry that you don't get excited about it, but I do. Okay, so when a person takes medication, okay, the medicine becomes effective as it enters the bloodstream. It can be useful to know how much medicine is in the bloodstream at different times. But they tell you don't drive a motorized vehicle if you've taken such and such a cough medicine or Sudafed or something like that because you might become drowsy. Well, Karen is a volunteer in a drug testing program at a pharmaceutical company. And the function, and I want you to look at this, is a negative 0.15 x to the third plus 1.05x approximates the amount of new medicine in her bloodstream after the medicine is taken. And this question was similar to the previous one. For which values does the numbers make sense? Just the positives, exactly. So you can see in this situation, again, we're going to be looking at maximums, minimums perhaps, but we're going to be looking at where they're located on the x-axis. Okay, so